KBYP with another foray into the HVAC/R world, heating, ventilation, air conditioning, and refrigeration. And this is the ubiquitous Schrader core. There have been billions of these made. Your car, your truck has 4 of these. Well, 5 if you have a spare wheel. There's probably a couple in the air conditioning system in your car. Bicycles have 2. They're in everything. They work great. They've been around forever. Until they work great until my train heat pump didn't have enough gas left in it to light a wet fart. Why? Because one of these on the high side of the sealed system and a access port. And the access port on these smaller units is a 1/4-inch male flare brass fitting with one of these Schrader cores screwed into it. It's the same difference as a vehicle valve stem, except it's brass, and it solders into the copper refrigerant lines. Otherwise, same core design. It was leaking. It wasn't cooling or heating quite properly. I thought since it wouldn't cool, the system was low on charge. It was. There was also a broken capillary bulb tube on the indoor TXV. It would not open and cool. It didn't make a whole lot of difference because there wasn't enough charge left to really work well. It had leaked out this high side Schrader through the plastic cap on top of the access port. Unforgivably sloppy design and manufacturing. One day I took the cap off, got a puff of refrigerant out. Put it back on, short time later, put the gauge on that same port, took it off, it was bubbling refrigerant out and bubbling oil with it. Put the cap back on. After snugging it down, tightening just a bit. Don't do that. Came back later, opened it up, I got a face full of refrigerant and oil blown out so bad it threw oil on top of the heat pump. Lost the entire system. That's covered in my other videos. I took the original cores out. They look like this. This is one of them. The seals aren't torn. Looks more or less normal. The low side core didn't fail, didn't leak. Why? Very simple answer. I did some online digging since I'm completely rebuilding this heat pump so that I can learn exactly how to do it and get all the parts and rebuild the other one because I have 2 of them. So I went online and I bought the best Schrader cores money can buy, and that's those. Those are from Schrader Pacific, a US company. There's one of them. Same design, same animal. The parts are the stem used to push down this cap. This cap has a seal inside it. It's a cup that seals against the bottom of this smaller diameter here. That's the body. This is a seal that seals the core against the inside of the access port brass fitting. Those are the nominal 0.210 inch 36 pitch threads that fasten it into the unit, into the access port. It's a screwball thread. And by the way, taps are available to retap these, to retap the access ports. While studying these cores, while looking at Schrader Pacific's technical information, I saw that these cores are rated for size, for max pressure, and for different chemicals such as air, refrigerant, fuel, and whatnot. I bought the best cores money can buy. These 4,000 PSI rated Viton seals. Viton is a version of Teflon. It's harder, it's stronger, it's extremely chemical resistant. I'd replaced these original cores with ones from the garbage JB Industries valves I got from Granger because I had nothing else at the time. When I changed in the system, I only had about 40 psi worth of vapor in it, so I just unscrewed them. I didn't have the proper tool at that time for changing these cores under pressure. But that's the correct tool, and that's a good one. So I just unscrewed these original. It was vapor gushing out. I screwed the JB cores in. They're the standard HVAC cores. I recharged the system. Went away to deal with learning about the TXVs and trying to resolve the question of what thermostatic assembly and what bulb it is. So I've got a new thermostat assembly, 45 ZGA. I went out to test putting air pressure on the broken capillary tube, which did make the TXV come on, did make the system run. In the process, I unscrewed the caps on the high and low side with these brand new best-in-class Schrader cores in, and the core on the low side is leaking. It built up pressure under the cap. I unscrewed the cap. It went. This is extremely bad. It didn't even get a month without leaking. Why? Why did it leak in the first place? And why did it reverse itself when I put in the best cores money can buy? If you watch my other videos, I explain that it's mandatory. In fact, the company that supplies this says that you must lubricate these seals. These seals, these black nitrobunus seals, NBR rubber, what common O-rings are made of. Seals like these, especially the ones that rotate, as in when these screw in, when this screws down, must be lubricated. If they're not, they're going to touch down on one side of that seal, catch and stretch the seal material, and it's going to leak. So I took some lightweight mineral oil, Q-tips, I lubricated everything, screwed these new cores in. Leaked. Why? Longer story, more research. Put briefly, these cores have pressure and also temperature ratings. The standard HVAC core, like on the left, is good for minus 20 Fahrenheit. This better core on the right is rated for minus 40 Fahrenheit. Back in the day with R12 and R22, the systems weren't quite so cold. But these are going in an R410 system, and the physical properties data for R410 is that when there's a discharge of liquid to atmosphere, R410 goes to almost minus 70 degrees Fahrenheit. And what's happening, and why when I access the high side with the original cores, that when I take the gauge hose off, how they'll give a burst of refrigerant. Well, it gave a geyser. It didn't just give a burst from the hose, it blew it out the Schrader core. And what is probably happening is that extremely cold liquid discharge on the high side, and it came out liquid. When I can see it, it ain't vapor. That discharge freezes that core, and that core is only making a marginal contact with that brass body, so it's going to get extremely cold. It gets cold, the seals shrink. The seals shrink, it leaks more. The seals get colder, they shrink more, and it goes into a thermal runaway. And it is a disaster. If you've got your face in the way without a face shield or safety glasses, you could end up in the hospital with burned corneas. So be very careful working around sealed systems. Always wear safety glasses. A face shield would be better. The core on the right is rated for minus 40 degrees with Viton seals. Just about the best plastic money can buy. Why did it leak on the low side? Well, in the process of the high side turning into a geyser, blowing refrigerant out, it also blew quite a bit of oil out. Probably a good half an ounce, and blew oil all over, up inside and around that high side access port, but not the low side port. lubricated the Viton seals, put them in with the proper tool. It didn't tighten them quite enough. They were leaking then. I tightened them down just a bit while they were still freshly installed. They stopped. And by the way, it's very difficult to judge a correct torque, which is supposed to be 3 to 5 inch-pounds, because of the resistance of turning this in the seals. The seals have to be really good or they'll leak refrigerant. So that's not the fault of the tool, that's just the way it is. But that's taking several ounce-inch to turn that. But anyway, the brand new core on the right was put in the low side port. The low side port had no discharge of oil. It was dry. But I lubricated all 3 cores, high side, low side, and liquid line. Why did the low side core leak? Well, I had forgotten my Teflon properties. That Teflon will not absorb oil. Teflon is extremely resistant to chemicals, except for basically hydrofluoric acid. That's why it's used. It's extremely chemical resistant, and it will not absorb oil. So I mistakenly put oil on a Q-tip and rubbed it around that blue seal thinking it would lubricate it, and it didn't. And that's why that core is leaking. The NBR seals, they'll pick up oil like a sponge. So the thing to do is I'm going to have to go back on the pressurized sealed system with this tool. This tool with the valve in line open reaches the stem through and catches the top of the Schrader core like this and holds it. Then it's unscrewed, and then when it's unscrewed, this button's pulled back and that pulls the core out back past the valve. Then shut the valve off, unscrew this, and take this cap, stem, and the core out. Then put a new core in and put it back in. Oops, didn't mean to drop you. When I do that, I will dip the entire core in oil so it's soaked. And I will probably, when I take the cap off to go to replace it, I'll probably put oil in that port. The data for R410 oil, POE, says that mineral oil is miscible in POE. Won't hurt it in the least. And I'll only be using a few drops. But I'll lubricate the dickens out of the inside of that, pardon the cough, inside that access core, that brass part. So when that screws in, that seal will seat. This is the same problem. That's why we lubricate the seal on top of the oil filters for our vehicles. There's a very good chance it'll leak if it isn't, because it'll first catch on one edge, one part of the seal, and stick and stretch. So the oil lets the seal smoothly sit down on whatever surface it's sealing against. So if you're seeing Schrader core leakage and failures that didn't exist years ago, yes, it could be cheap Chinese junk cores out of China. But again, I bought the best there is, and it leaked. It's the refrigerant. Back years ago when it was R12 and 22, the refrigerant wasn't nearly so cold. This R410 gets extremely cold. That's why they use it. It can transfer more heat. It's more efficient. It's also, as I found out the hard way, it's death on these Schrader cores. This problem can happen by putting a manifold and gauge hose on the high side port. Open the core, push down that pin to connect the hose. It gives out a burst of refrigerant and starts to freeze that thing. That can start the failure cascade right there. So the thing to do is that there's a tool for that, and that's this. That's called a core depressor. This screws on the access port with this unscrewed, and there's a pin up inside there. This screws on the port without depressing the Schrader core and seals off the port. Connect the manifold gauge hose to that, and then turn this screw in, which will push that pin against that stem right there and depress it and pressurize it. And there's no need to leave that thing screwed in. To check the pressure, and we never charge a high side unless it's maybe a small refrigerator. On this heat pump, we don't charge high side. That's a risk of possibly damage. But there's no need to leave that depressor with this screwed in. Screw it in till the gauge gets a reading, screw it back out. And that prevents that big discharge of refrigerant through that core that could freeze it. So there is an engineering failure analysis of why these cores not only leak, but they basically go into a catastrophic failure that's called thermal runaway. Thermal runaway is temperature causing some kind of failure that gets worse because of the temperature change, and it's a vicious cycle. A little bit of leak, more freezing, seal shrinks, leak gets bigger, more freezing, and it doesn't stop. And that's exactly what I saw happen. So there you go. KBYP did it.